A lot of exciting things to talk about what has been new in astronomy. So I will welcome Sam and Dom up to the stage.
Hello, and welcome to Astronomy in the News for March, I think. Yes, it's March. Welcome to the life of a postdoc. I don't know what month it is. I am MCMC Hammer, a.k.a. Dr. Sam Factor.
And I'm Dominique Segura-Cox. That means I'm Barbenheimer. So, big news story, not that we've told you before, you might be completely unaware of it, is the eclipse is coming, right? Okay, so this is not going to be my first eclipse. I saw the 2017 eclipse in totality. I went into prisons and taught prisoners how to view it safely, like from the prison yard. So I'm going to tell you in just a few minutes how to view it safely, how to know when to take the eclipse glasses off, and what to expect. Okay. Nope. Oh, I've totally destroyed everything. We're calm. No, we're calm. We're calm. Go back. Okay. Yeah. So I think we've already mentioned it, that the traffic's going to be crazy. So think about where you might want to be ahead of time. And one thing to consider, how am I going to do this? Sam, I'm going behind you. This kind of reaches. Okay. One thing to consider is that Austin is going to be definitely in totality. You will get totality in Austin for 1 minute and 46 seconds, which is awesome. Great. But if you're planning to drive somewhere scenic, like, I don't know, maybe you want to see it in like some state park or some barbecue, Fredericksburg, perhaps. Exactly. So what we have here is actually the map of where totality is. Whatever you do not go east. Don't go east. Okay? You will not see the total eclipse. You can go west or you can stay right here in Austin. It's going to be amazing, but don't go east, okay? If you actually want to see like more minutes of totality in the nearby area, yeah, Fredericksburg is almost at peak totality and they have almost 4 minutes of totality. The same with Marble Falls, and I think off the map is like Burnett. It also has a lot too. So there's a lot in slightly west of Austin areas that you can see. Lots of great totality. Again, don't go east. And because traffic is going to be really crazy with a bunch of tourists, sorry, my parents included. I mean, so do my parents. Right? So just if you do want to go somewhere outside of Austin to view the eclipse, plan ahead, leave early in the morning and plan to basically like camp out at your car wherever you're going to go. So like, you know, wake up like at the crack of dawn and get going, or else you're going to be stuck in traffic and really upset and probably going to wind up seeing your eclipse from a Buc-ee's, which is great, actually. They have lots of great facilities. All right, next one. Okay, but what are you actually going to expect? So first off, go get your eclipse glasses. Like, I'm going to put these on right now. I can see nothing. Like, I'm staring down into this really bright spotlight, and I can barely see it. Like it's super safe. So get these glasses. You want to use these glasses. Do not use welding glasses. Don't use like regular sunglasses. And there's a lot of workarounds that people use. But if you're going to use something that you put on your face to look at the sun, make sure that they are official eclipse glasses. And we have some to give away. And when I say some, I mean all of you. Take some for your neighbors, your Aunt Carol, Uncle Jose, I don't care. Like, take lots for your family over here from merch. It doesn't have to be just for you. It could be like your mortal enemy that you hate. Give them eclipse glasses, please.
Sell them to your quote-unquote friends. They need them. They want them.
Yeah, MCMC Hammer is smart, and that's why I keep him around, okay? So, like, follow him. Yeah, take our glasses and sell our glasses. So, basically what you want to do is you want to use your eclipse glasses to look at the sun at almost all times except for during totality. So, a lot of what you're going to see during the eclipse is going to look kind of like this. It's going to be either like a chunky crescent looking thing, or maybe it's going to look like a cookie that Cookie Monster take one bite out of. Whenever it looks like that and you can see that round disc of the sun, you put these eclipse glasses on, okay? So like here I am, I'm staring into the spotlight, right? Like I'm super safe. Do that whenever you're going to look at the sun. Next one. Okay, but as you get close, these are the signs that within a few minutes you can take the eclipse glasses off, but not yet. When you see this, you keep your eclipse glasses on. Both of these images on this slide. Keep them on. Okay, so the first off is what's called Bailey's beads. And it's from some astronomer dude named Bailey. That's why they're called his beads. He was the first to, write them down and talk about them a lot. That's how this happens. But what that is it's the sun shining through the craters on the edge of the moon just before the sun has completely set. And this is like less than 2 minutes to totality. So when you start seeing Bailey's beads and you only see those points of light on the edge of the sun, but multiple points of light, all right, don't take your glasses off, but don't take your eyes off the sun, okay? Because the show's about to start. Okay, the next one is the diamond ring effect. So what that is, it's the very last crater that the sunshine is peeking through on the moon. And then as soon as that diamond ring effect goes away, as soon as that really bright spot right here leaves, then you can take your glasses off, and only then. Because that means that there's enough of the disk of the bright sun that's going to blind you that's actually been covered by the moon. So next. Jed, that's supposed to play. Okay, so this is what it looks like in real time. This is a science YouTuber, Derek at Veritasium. His name is Veritasium on YouTube. He's a physics education researcher. He's trained in this. It's actually a really cool video if you go look it up. So it's, again, Veritasium. But this is what it looks like in real time. So the part that keeps looping, this is the diamond ring going away. And then at the very end of the video, not yet, that's Bailey's beads. Now it's diamond ring. Now you can take it off, right? Because it looks really smooth and uniform on the outside. So as soon as those bright points of light on the outside leave, take it off, because then you're going to have totality. And also, this image is garbage. This is not what it looks like. This is beautiful, but it ain't it. Like, the eclipse is like the defining moment of my life. I don't know, not really.
It's life-changing. It's life-changing.
I think I just carried on with what I was doing, but I really wanted to do what I was doing more. Like, it's the most beautiful thing I've ever seen. It blows my mind. So some things that you can expect during the eclipse are, for instance, as we're approaching totality, as that light's going away, even when it's still crescenty, not only when you just have the Bailey's beads or the diamond ring, when you get all the way up to like 93 or 94% totality, that's when it still looks like the smiley face. That's actually when you can start to see like the light around you dimming noticeably, like it's twilight. And then eventually, when enough of it is covered, you can look around and it's a 360-degree sunset. Like, it's red everywhere, all around us. Blows my mind. It's because we're blocking all the light from the sun that makes the sky blue. So, of course, it's going to turn into twilight mode. The animals get weird. So, like, I saw that, right, remember, this is going to be at, like, 1:36 p.m., but, like, in the middle of the day, mosquitoes will rise up and attack you because they think it's the evening. I saw bats come out to eat those mosquitoes. The birds get quiet. They're like, nah, it's nap time. Crickets start to chirp in the middle of the day. It's very eerie and strange. And also, this winds up covering a lot bigger portion of the sky than I expected. So all of the wispy stuff, the corona that you see coming off the sun, it kind of has this like streamery tail kind of look to it, but sort of spread out all over the place, all around the edge of the moon. And that's us literally looking at stuff that's like just streaming off the sun. And I expected it to kind of be like this image, but from what I've seen from the 2017 eclipse, our cameras and our technology just can't get the difference in brightness all like on the same like digital camera. Like we have that photographic limitation, but your eyes don't. So you see with your eyes regions that are much dimmer that your camera won't pick up. Even I've seen like lots of amazing eclipse specialty photographs. Again, still nothing compares. So the wispy stuff, the corona that's coming off of the sun, actually probably took up like, I would say would like go out to like, maybe out to here. It's big, yeah, as Sam says. It's big. Like it goes really far. So you're gonna be able to have this once in a lifetime experience and see something that not even cameras can pick up. Nobody will be able to ever tell you, and I'm trying really hard here, how amazing this is. So don't miss it. And if you're going to be in school, skip it.
UT is canceling classes for like an hour during the eclipse. So yeah, don't miss it.
You're going to learn so much more from watching the eclipse than going to class. Like, this is the only time I'm going to say skip school, but it's worth it. Okay?
But also, don't hurt yourself. Please wear your eclipse glasses. Please take our eclipse classes so we don't have to take them home.
Take many. Yeah. Yeah, that's a good question. So I'm going to go to a state park just west of Austin. I forget what it is, but it's basically a field with a historic barn. Yeah, so I'm going
Plan
west.
Plan ahead.
Yep.
Figure out your plans. There's going to be traffic. Okay, next story. We gotta keep moving. Okay, so our next story is going to be kind of a whirlwind tour of a bunch of stuff that's happened in our own solar system this past month and a little bit longer than a month. First, you may have heard that Voyager 1 is having some issues. Voyager 2 had some issues a while ago. They fixed it. Now it's Voyager 1. It's sending back gobbledygook transmissions that don't make any sense. There's a problem with one of its computers. Yes, they've tried turning it off and on again. It didn't work. This computer is almost 50 years old and still chugging. It's having some issues, probably some like corrupted memory. The last prod that they gave it, it returned something kind of intelligible that will hopefully let them figure out what the more root issue is. So there's some hope. Moving on, there have been a bunch of action on the moon. Not the next slide, just the next sub-topic. There's been a bunch of action on the moon this past month. Intuitive Missions, a private company, landed their Odysseus lander on the moon. This is part of the Eclipse program, the Commercial Lunar Payload Services program from NASA. This is the first time that an American spacecraft has landed on the moon since Apollo, so that's pretty big. Other countries have done it, so yay them. Unfortunately, it kind of fell over when it landed. This is not the first time that a lander on the moon has fallen over. Japan's lander about a month earlier fell over, but it's still worked fine. They got a bunch of cool pictures and stuff. It took a little bit longer to get the data back because the antenna wasn't pointed at the right place, but yay, landing on the moon. We're going back in the next few years with people, hopefully. Finally, and probably the biggest story close to home is Save Chandra. The NASA 2025 fiscal year budget came out, or the proposal came out, and unfortunately NASA is taking a big budget cut of not big in terms of percent, but big in terms of dollars, 2%. And unfortunately, they have proposed to essentially cut Chandra. This is the Hubble Space Telescope of X-ray astronomy. It has been going for almost 25 years now. In a few months, it'll be 25 years. It is still going strong. It has roughly a decade left of good science to do. It is still churning out papers, churning out science. The budget is basically just the people who run it. So it's relatively cheap compared to how much science it's putting out. Go to this website, savechandra.org, contact your representatives, tell them to fund science, tell them to fund NASA, tell them to fund Chandra. Long live Chandra.
Let the NASA people keep their jobs.
Yes, absolutely.
Okay, so I kind of thought I was done with the eclipse, but then I forgot about this thing. So there's this comet called the Devil Comet. And it's called the Devil Comet because if you see this picture over on the edge of the stage over here, that big white one, like instead of being like a ball of ice that's hurtling through space, it's kind of got like these devil horns. Although I think of them as Jed, my joke. I think they look like hook'em horns though, so I don't think it's the devil. Thank you, Jed. But fun thing that happened is that in December, we took, well, actually, all of these images that are on the screen here were actually made by amateur astronomers and amateur astrophotographers. So, like, it's not just the big telescopes that do amazing work. Like, some of these were made with, like, you know, point and shoot cameras that, like, photographers have, like DLSRs and things like that, like professional photographers. So you don't need a space telescope for amazing images all the time. For instance, when you're working with comets, and if you're a big fan of comets and taking pictures of them as a hobbyist, they might have noticed this, which was this comet has sort of lost its devil horns, which it was quite well known for, and it kind of turned green. So what we think happened with that devil comet is that it's not that the horns were like something in particular, it's that part between those horns, that dark part, you know, your two middle fingers in the hook'em horn sign. Those two middle fingers are actually probably had a slightly different material that had a much lower melting much higher melting point. So the other pieces of the comet had all this stuff flying off of it, but for some reason it also kind of had a helmet on. It was made of a slightly different material in that spot, but it seems to have either flaked off, or as this comet starts to approach the sun, the temperature might have gotten warmer and then it also sort of fell off too. But it seems to have revealed sort of a different chemical composition, which is why it changed colors. And right now, it's not visible to the naked eye, but it's expected to be very soon, including during the total eclipse. So if it is visible during the total eclipse, this is sort of the part where you got to make it angry enough. If you can get it to have like another one of those like devil fits where it's throwing off a lot of material, like when it had the horns, it can get really, really bright. It can get like 3 or 4 times brighter than what it would normally be at. And as it gets closer to the sun, which it's continuing to do between now and the end of April, eventually a lot of that material will wind up either melting or sublimating, and that means that the comet will wind up giving off gas and ice material to make this long cometary tail. And this one was this picture with the long tail was taken only a few weeks ago. So it's happening. There are changes occurring. If we're lucky and it happens to have some extra stuff flake off or it gets really bright really suddenly, it will be visible during the eclipse. And if you see it, it will be about 25 degrees away from the sun, which isn't that much. So if you do your hook'em horn, that's 15 degrees across on the sky. And if you just make a fist at arm's length, that's 10 degrees. So one fist plus one hook'em horn means, you know, it's like that far away from the sun. So The thing that I will caution of, even if technically it might be bright enough to see, it might be close enough into the bright corona, that material that's streaming off the surface of the sun, that it might sort of be fuzzy and hidden with that. So you won't be seeing something like this. This is done with like a lot of integration time, like a lot of different frames stacked together.
This is also at night.
What?
This is also at night.
This was at night. This was at
Eclipse
night.
gets dark, but
Yeah.
not nighttime dark.
But there's a possibility that if you happen to be looking up and you see a green smudge about yay far away from the solar eclipse, then you might be looking at this comet. So the question was, is it going to be visible closer to sunrise or sunset, not visible during the eclipse? So the answer is it changes quickly, so I'm not actually sure which side of the sun it's on during that date. But if you look up Devil Comet, that's like its common name, and you'll be able to find lots of information about
I
it.
think during the eclipse, it's going to be on the left side, like roughly halfway between the sun and Jupiter. So, yeah. Cool. Next slide, please. This is our last story. So this is a story that's a little bit near and dear to my heart. JWST, a scientist at Space Telescope, I'm blanking on her name, Susan Mullally, has used JWST, the mid-infrared instrument. MIRI, aren't astronomers great at naming things, to take a bunch of very high-resolution pictures of white dwarfs, which are kind of the end state of stellar evolution. Our sun will become a white dwarf eventually in 5 billion years or so. And they took these very high-resolution pictures to look for planets around these dead stars. And they found a couple. They found 2 that are roughly a few times the mass of Jupiter, orbiting around the placement of Saturn and Neptune in our own solar system, so a few tens of AUs. And this is really cool because as stars evolve, they grow into what's called the red giant phase, and they get very, very big. When the sun goes through this phase, it will eat up Mercury, it will eat up Venus, it might eat up Earth. We don't really know exactly how big it's going to get. But it won't get big enough to eat Jupiter and Saturn and all the gas giants. But that isn't to say it won't affect these planets. So right now, these are just candidate. We need to go back and confirm that they're actually real. But if they are, they would be really cool to study and kind of compare to similar planets around more main sequence regular stars and see how that stellar evolution has affected these planets. So, yeah, that's the news for this month. We will see you next month.
Get your eclipse glasses.
Yes. Plan ahead.
All right, let's give these two a big round of applause. Thank you so much.